Hello, dear students. How are you? I hope you are doing good and you are focusing on your studies right now. Now, I welcome you all in this session of question discussion with the AIT 3 JEE. So I hope that all of you have attempted in your recent examination paper. So, as the previous year AIT question discussion, we follow the same strategy here. I have suggested or I have selected some question based on the difficulty level of the questions. So what we will do, we will discuss them one by one and see the concept behind it and what can be really tricky to solve that questions. Okay. So without wasting so much of time, let's just get started with it. Okay. So here is the first question on your screen. Yeah, this is the first question on your screen. A particle y and x coordinate are given as y is 50t plus 25t square plus 5 and x is 25t plus 25t square. Some quadratic equations of time in y and x are given. So what is the shape of the path along which this particle moves? So first of all, this is not a straight and this is not a circle or any and not hyperbola, because for hyperbola the relation should be 1 by x type. So the only option that can click in your mind is parabola, and the right answer is also parabola. But how we can check it mathematically, that we can also see that here y is equals to 50t plus 25t square plus 5. So if I calculate dy by dt, which is nothing but the velocity in y direction. So dy by dt is equals to 50 plus 50t plus 0, which is 50 times t plus 1. Okay. And if I just click with acceleration in y direction, which is dy by dt, dvy by dt is equals to 50 only, because this 50 differentiation will be 0. 50 into t will be 0. So this is a constant quantity. Means acceleration in y direction is constant. Now if we go for x, x is 25t plus 25t square. Now calculate dx by dt. So dx by dt here is 25t. 25 plus t square differentiation will be 2t, so it will become 50. Now this is what? Velocity in x direction. Now if I calculate the acceleration in x direction, it will give the same value. Acceleration in x direction also 50 times, or meter per second square, you can say. So from here, in this equation, we can easily say that acceleration applying on this on both the direction, x-axis and y-axis. But acceleration is constant. And since velocity here, if you write the velocity expression, it is 50t plus 50 j cap plus this is 25 plus 50 t into I cap. So clearly you have both the component in x direction and in y direction also. And acceleration is also applied in that case. So clearly the path should be parabola, because this particle is moving in x and y direction. Clear? Now, move to the next question. This. How much force is required to lift the ring from the surface of the fluid having surface tension S? Because in your AIET examination for 12th class, they are also having 11th class portion. Okay, so that is why these are the questions that I have selected from the 11th. Now, in this question, if you will see, there is a ring which is dipped in the water and is given to you. So suppose this is the ring which is placed inside the water. When you try to lift this ring, only the portion that is in contact with the liquid is this, the periphery of this or the circumference of this ring. So when you try to lift it, due to the cohesion forces or adhesion forces, cohesive forces, adhesive forces. I think you have an idea about it. So cohesive force is that force which acts between the same particles, okay, same atoms. And adhesive force is that force which acts between different sets of atoms, different sets of particles. So here, what is another different medium? And this ring is made up of some other materials. So we have two different materials. So the forces in between them is adhesive forces. So this adhesive forces is try to resist the upliftment of this ring. When we try to uplift this ring, it's very obvious. When you try to lift it against its mass also, against the weight of this ring also, there is another force also, which is the surface tension, which is developed on the surface of this ring. Okay? Got it? So if I see the net force that is required, let's say that is F, is equals to the weight of ring plus surface tension of the ring. Surface tension force. Okay. So weight of the ring is very simple. Mass is given as mg plus surface tension force. You can easily calculate that surface tension is nothing but force per unit length. Okay. The length over which the force is applied. So in this case, you can say the length that is in contact with the liquid is the circumference of this ring on. Okay. So the circumference of the ring is the length over which the surface tension is. But here's a hack. Here we have a water film. Okay. So that is why we have twice of the film here to apply the force in terms of surface tension. Although if you see the circumference of this ring is 2 pi r. Okay. So force must be S into L, which is S into 2 pi r. But there are two faces of the surface. So that is why an extra 2 is also multiplied here. We can say this is mg plus S into 4 pi. Okay. How simple is this? The option is the correct. Okay. I hope you got it. Now move on to the next one. Yeah. Now we have two balls of same mass traveling with a speed 14 meter per second. Each had a head-on collision. Calculate the rest and the coefficient of restitution is 1 by 2. The speed of each ball after impact will be. So this is a pure question of head-on collision. And coefficient of restitution is also given. So firstly, we will write what is given. Given data. So given data, we represents coefficient of restitution as E. So the value of E is given here is 1 by. Although another things are also given, which is the two balls of same mass. Let's say these are the two balls and they are traveling with the same speed of 14 meter per second. Okay, no? In this direction and in this direction also. Okay. So the speed of them is 14 meter per second and 14 meter per second. Okay. Clear? And mass of the rings, mass of the balls are same. Let's say mn is equals to m2, which is equals to m. Now it's asking for the speed of each ball after the impact will be. So it's very simple. We know that the coefficient of restitution, and let me write it completely so that you will have a better understanding. Coefficient of restitution is given by velocity of separation divided by velocity of approach. Okay. Now, what is velocity of separation? The velocity of separation is defined as the velocity after the collision, and velocity of approach is the velocity before the collision. Okay, so I'm going to write it also here that velocity after collision is the velocity of separation. Velocity before collision is equals to velocity of approach. And these are the velocities. So we must be careful about the directions. Okay. Now velocity of separation, let's say after the collision, the balls are moving with the V1 and V2 velocities. Okay. Now this is V2 vector minus V1 vector divided by velocity of approach. देखो, these two balls are approaching towards each other. Okay. So we can say the velocity which is 14 meter per second and 14 meter per second, they are opposite in direction, and opposite direction velocity will be always adding up. So it will become 28 meter per second. 14 minus minus 14 will be 28, and this is 1 by 2 given to us. So this will give you 14. So V2 minus V1 is the 14 meter per second. Okay, clear? Now since this is a head-on collision, so we can say because these balls having same mass, m1 is equals to m2, which means the velocity after separation is also distributed equally. Clear? So we can say that here, if we just talk about the magnitude, so V2 is equals to V1, and we can ignore this sign also. So we can say that twice of V2 is equals to V1 equals to V. So twice of V is equals to 14 meter per second, which is V is equals to what? 7 meter per second. Okay. So the velocity of each ball after the collision will be 7 meter per second. Now, I hope you got this. Move on to the next question. This assertion and region type of question is given here. The assertion is given as that two concentric charged spherical shells are given. The potential difference between them depends on a charge on inner shell. The reason is potential due to charge of outer shell remains same at every point inside the sphere. देखो, चलो, let's try to solve it. So if I talk about the potential difference between these two concentric cells, so it is given by k q1 upon r, k q1 into 1 upon r1 minus 1 upon r2. So similarly, you can say that the potential difference is depends only on the charge present on the inside. This is very clear, which means the assertion is very clear. Assertion is very right. Assertion is true. Now, what is the reason behind it? Let's just take. So suppose we have a spherical shell. Okay. The inside of this shell, the electric field will be zero. So if electric field is zero, we can say that dV is equals to minus E dot dr, which means dV by dr is equals to E, and E is zero. which means the change in velocity, change in this potential with respect to the distance, with respect to position, is always constant. That is also satisfying. And that is why inner shell inside the potential is constant. So that is why the potential is counted on basis the charge that is on the inner surface. Because for the inner surfaces only, the potential between here, in between the gaps, is the outside, counted at outside of this sphere. Okay. Because if you count it on the basis of this charge Q2, so potential is same everywhere because these points are inside of this bigger shell. So that is why we can say that assertion is also true, reason is also true, and reason is a correct explanation for assertion. So option A is a correct one. I hope you got it. Now move on to the next question. Yes. An infinite non-conducting sheet has a surface charge density of 7 into 10 raised to the power minus 7 centimeter coulomb per meter square on one side between equipotential surfaces whose potential differ by 19 point. So the distance between the equipotential surfaces whose potential differ by 19.8 volt will be. Now again, as the previous one, we are going to apply this approach. Now, this is an infinitely long non-conducting sheet. Let's say this is charged with positive charge equally, and this is a non-conducting sheet. So charge remain where it is. Charge will not move. And the surface charge density of this sheet is given as on one side is 7 into 10 raised to the power minus 7 coulomb per meter square. Okay. Now, the distance between the equipotential surface. Now, firstly, we will know that if this is a sheet, so what kind of equipotential surfaces it will generate. So we definitely know that the charge line, the electric field lines is parallel to each other. Uniform electric field lines it will generate. So equipotential surface is that surface which is perpendicular to these electric field lines, or electric field lines remains always perpendicular to that surface. Okay, which means the plane same as the plane of this sheet will be a equipotential surface. Now again, this is, I must draw one another surface also. So let's say these are two equipotential surface at V1 and V2. These are the potential. Separation between these two plates are given as that we have to calculate. So let's say D is the separation in between them. The potential difference between these plates is, let's say V2 minus V1 is given as 19.8. Actually, I have to write V1 minus V2 because as you move in the direction of electric field, the potential will decrease. Okay. So I will correct itself like V1 minus V2 is 19.8 volt. Okay. Now we know the relation that delta V is equals to minus of E into delta R. Now delta R is the separation between these two plates or between these two surfaces over which we are calculating the difference of potential. Delta V we can write V2 minus V1 is equals to minus into E, and delta R is nothing but D. Now V2 minus V1 is minus 19.8 because it is V1 minus V2. So it is 19.8. Okay. Okay, so we are here with 19.8 potential difference, which is equals to minus of E into D. And D is the actual target that we are having. This will become minus 19.8 because this is V1 minus V2, which is actually given us. And this is V2 minus V. So this minus and this minus cancel out. 19.8. Now we know the formula that for a non-conducting thin sheet, the electric field intensity per unit volume, when we apply the Gauss law, we derive a result that electric field is nothing but sigma upon 2 epsilon naught, where sigma is the surface charge density of that particular sheet. Okay. Now, this is electric field, which is sigma upon 2 epsilon naught. Sigma is 7 into 10 raised to the power minus 7 given to you. Epsilon naught is what? Epsilon naught is permittivity of free space. Okay. So epsilon naught is the relativity, or sorry, permittivity of free space, which also has a value of 8.85 10 raised to the power minus 12 and into 2 because it is 2 epsilon naught. Okay. Multiply by d. So when you calculate sum of these distances, you will have a value of 0.5 mm. Okay. So option D is the correct option. Okay. Okay. So let's just move to the next question. Thus, a wire ABCDEF with each side of length L, bent as shown in figure, is carrying a current. Okay. So these are the wires which having same length. So this is carrying current I. It is placed in a uniform magnetic field B parallel to the positive y direction as shown. What is the magnitude and direction of force experienced by the wire? Okay, so this is the simple question, by the way. Now, these are the wire, the 1, 2, 3, 4, and 5. So there are five number of wires are five. Number of wires is 5. Okay. And each wire carrying a current, and the length of each wire is length of each wire equals to what? Capital. And each wire each wire carries a current equals to I ampere. Okay. And there is a magnetic field also which is in the positive y axis in this way, like this. This is the direction of magnetic field B. Okay. Now, we know that if any kind of conductor which is placed in a magnetic field, the force on the conductor is I into L cross B. Or simply it is dl cross B for an entire length. We can say that it is L vector cross B vector. So on the each and every wire like AB, if you count the wire as AB, BC, CD, DE, and EF, the force is applied. Okay. And we just have to see what is the direction of these force and what is the magnitude of these. There are some forces which is going to be cancelled out. Okay. There are some forces which going to be zero. So we have to play according to the direction. So first of all, if I talk about AB wire. So for this AB wire, if you will see the current element, that is the length vector, you always have to take in the direction of the current flow. So here for AB, if you will see, the length vector is in this direction. This is L vector. And the magnetic field vector is also in the same direction. So the angle between them will become 0 degree. So in that case, sine, if you open this expression, it will become BIL sine theta. So theta is 0. So sine 0 will become 0 degree. So this force will become 0. So on wire AB, the value of force is 0. Similarly, we can say for this also, if theta is 180, sine 180 is also 0. So for wire EF is also 0. Now we will have to calculate for wire CB. Wire CB having a length vector in this direction downward, and there is a direction of magnetic field in this. Both are perpendicular to each other, which means theta is 90 between them. Theta is 90 degree. It means that force is BIL basically, because sine theta is sine 90 is 1. The maximum force we have BIL. Now the direction of force is apply, you can calculate by the right hand thumb rule. You just have to curl your finger from L to B. So L to B, if you curl, the thumb is pointing outward, which means the force it is experiencing in the direction of X or in the X direction. Let's say this direction is X. So this is the force. If you see the similar wire parallel to this CB, which is DE wire, the force will be in the opposite direction, because here the only change is of length vector. So L cross V be now into the plane, which means the force is in negative X direction. So these forces having same magnitude but opposite direction, they will cancel out each other. So combined on BC and DE, the force will be 0. So the only wire that is remaining here is CD, which means it will only contribute in the force. So CD has a length vector in this direction. Okay. And the magnitude of magnetic field in the positive y direction. And this is in the X direction. This is X direction and this is length vector. So L cross B is pointing upward. Pointing upwards means this pointing upward direction is positive Z direction. So positive Z direction, this, and the magnitude is always, because this angle is 90 degree. So force will be BIL. So magnitude is BIL and the direction is positive Z direction. So this is the way you can calculate. So in these types of question, just see which length vector is parallel to the magnetic field. Remove them because the magnitude is 0 there. Okay. Now, move to the next one. This. Two coils have a mutual induction of 0.005 Henry. The current exchange or the current changes in the first coil according to the equation I is equals to Im sine omega t, where Im is the 10 ampere and omega is 100 pi radian per second. The maximum value of EMF induced in the second coil is. So this is the question from mutual induction. So first of all, we will write the value what is given to us. So here the given data is like mutual induction M is given as first of all 0.05. This will simplify the solving of your question. And the equation of current which is induced in the first coil is Im sine omega t. Okay, the value of Im is also given to you as 10 ampere and the value of omega is also given to you as 100 pi radian per second. Now, we know that the maximum EMF induced in the second coil will be given by phi is equals to, in the second coil, is M di by dt. Now, you just have to differentiate this expression. M di by dt will become, Im is constant, sine omega t will be cos omega t, and then further, omega t will also be differentiation. So, this kind of differentiation is a chain differentiation. Okay? So, let me do it here, sine omega t d by dt. So sine omega t will become cos omega t, and then again cos omega t will become omega, because differentiation of t with respect to t is 1. So it will become omega cos omega t. Okay. So it will become omega cos omega t. Now we need the maximum value of this pi. So for phi is to be maximum, this cos omega t should be maximum. because this cos omega t is only the time dependent variable. So when this will be maximum, the phi s will be maximum, and this maximum value is 1. So we have phi maximum is MIM omega. Okay. Now you can put the value. This is 0.005. IM is 10. And this is 100 pi. So this 30 will remove these 30. So it will become 5 pi volt. This is the, sorry, this is EMF induced, not phi. EMF induced. Okay. Emax. This is also Emax. Okay. Emax. Okay. Okay. Move on to the next question. This one. So this question, by just seeing, this question is from motional EMF. This is the guess you can see by just by seeing this question. Okay. Because there is some wires and there is a movement of wire and some magnetic field is also present here. So we can see that this kind of question is from motional EMF. So here in the question, the loop ABCD is moving with a velocity v towards right. Magnetic field is 40. The loop is connected to a resistance of 8 ohm. If steady current of 2 ampere flows in the loop, then the value of velocity, if loop has a resistance of 4 ohm, okay, is given. So first of all, we will write what the given data is. Given data here is, there is a loop which is given, magnetic field 4 Tesla is given, the resistance of the loop, so let's say R of loop is given as 8 ohm, and the resistance, resistance which is connected to the loop is 8 ohm, this, and resistance of the loop itself is 4 ohm. Okay. Now, velocity V we have to find out. Current also is given to you as 2 ampere. Okay. So if I just apply a formula that I is equals to what? Potential difference. Potential difference divided by resistance. So if you just simplify the circuit here, the 8 ohm resistor is directly connected to the 4 ohm resistor of the loop, which means there is a series connection in this case. This is the resistance of loop, which is 4 ohm, and this is the resistance which is connected to the loop. So they are in the series. So the total resistance that we have as 4 plus 8 is 12. Potential difference we do not know, so we assume it as E. Okay. Divided by resistance is what? 12. Current is given as 2 ampere. See, from here, from this equation, we can have that EMF induced due to which this current is flowing is 24 volt. Okay. One of the formula we also know that EMF induced is nothing but one of the formula we also know that EMF induced here is given by L V cross B. So here the only length which is perpendicular, if you just resolve this length, this AD length, if you just resolve it into two components, so one of the component is in perpendicular direction here, and one of the component is in horizontal direction. Okay. Clear? So when you take this horizontal component of this velocity of this length, this is the only way, like this way. This is moving with velocity v, and this length is also perpendicular, and b is also perpendicular. So three of the quantities, which is b, v, and the length, are mutually perpendicular, and this is not happening for the other cases. If you calculate it for DC, calculate it for AB, they are, the length is parallel to V. So in that case also it will become 0. So simply we have a formula for this. that epsilon is equals to BLV. But the length here you have to take, which is perpendicular to the velocity, perpendicular to the field also. So this is that field, the component of AD. So the component of AD, which is that length, is AD. This angle is 37. So you can resolve it into two components. This one, cos 37, and this one, the perpendicular, is sin 37. Now, AD is what? AD, we have a value of, which is given to us, 30 centimeter. Multiply by sin 37 will become 3 by 5. Okay. So it will become 18 centimeter. Now you can put the value 24 volt is equals to what? 4 into 18 centimeter ko you must write 0.18 because we want to calculate the velocity in meter per second. Divide, multiply by V. So when you calculate this, it will become 100 by 3 meter per second. Okay. That's one. So option C is the correct one. Clear? Okay. So move on to the next one. Here also, this is the last question of the discussion. So it's a very simple question, but yet very important. So here a block is given to us on which the forces are applied. F1 is equals to 20 Newton. F2 is equals to 10 Newton.